Hello, I welcome you all. The problem reads we have a brick here that weighs 2 pounds and it slides down a smooth roof. So by smooth here we mean no friction, such that when it is at A it has a velocity of 5 meters per second. Determine the speed of the brick just before it leaves the surface at B, and the distance T from the wall to where it strikes the ground, and finally the speed at which it hits the ground. This problem is coming from the Engineering Mechanics and Dynamics, 14th edition by R.C. Hibbeler. We're going to use the concept of work and energy. So we have KE1 plus, say, initial kinetic energy. The total work done is equal to the final kinetic energy. Alright, so let's start with the speed. So let's say speed at B. Okay, so we have VA. Our VA here is just equal to 5. Then we have HA, okay, which we are going to call equal to 15. Then our VB is equal to unknown, that's what we are looking for. And then HB is just equal to, I'll call it 0. So let's work out this. So we have half M VA squared plus the total summation, the total work. And when you look at this, let me draw the free body diagram there. We do have the weight like so. We do have the weight acting through the center of gravity like so, and then we have the normal force. So this is the normal force, this is the weight like so. So we are saying the total work here being done, the weight, okay, is acting in the same direction with the displacement, therefore we have positive. So this just becomes WHA, then this is equal to half M VB squared. So our VB is just going to be equal to 0.5 MVA. So let's put numbers there. 0.5, our M is just 2 divided by 32.2. This is the acceleration due to gravity, because the weight is given in pounds, so we need to convert it to mass, which is slag, right, for these units. And then this VA is just 5 squared, then plus 2 by h, which is a 15. Then we are dividing everything by 0.5. The mass again is 2 divided by 32.2, and then we are squaring everything. All right, like so. Therefore, if we calculated what VB is, VB is just going to be equal to 0.5 by 2 divided by 32.2 times 5 squared plus 2 by 15 divided by 0.5 by 2 divided by 32.2, and square root of that, we have 31.48 feet per second. So found BB. We'll go straight away to find, let's call this one as AB, let's call it C. Okay, just before it hits the ground. So let's say speed, okay, at C. Okay, so let's work out that one. So here we're working on this, here we're working on speed. So again, there are two ways of solving this. So we'll say our VA, okay, is equal to 5. So we can solve this directly. Just write an equation here. So you say 1/2 m. We can solve this by just using this equation VA like so, plus W from that point, and we'll call this just HC. Okay, then this is equal to half m VC squared. So we can solve this. This is one of the ways, and our VC is just going to be equal to 0.5 by m, which is just a 32.2 like so, and VA5 squared plus W, which is just a 2 by HC, and our HC is 45. Then we divide everything by 0.5 by m, which is just a 2 divided by 32.2. Okay, there we go. And then we have VC. VC is just going to be equal to 0.5 by 32.2 divided by, 2 divided by 32.2 by 5 squared plus 2 by 45 divided by 0.5 by 2 by 2 divided by 32.2 like so, like so, and square root of that, we have this. Let me check it once more again. We have a 54.06. We check it. 0.5 by 2 divided by that by 5 squared plus 2 by 45, then 0.5 by 2 divided by 32.2, and square root of that, we have 54. So this is one way of solving this. You can also solve this using another way, which I just want to show right now. Let me go in like so there, and then I come out. I guess this is not bad. So we can solve, or again this is an alternative, or another method for speed HC. So we'll say half. So this is another technique, not really a technique, it's just a direct way. Instead of using, we use the velocity at B. We found the velocity at B, so we'll say half mvb squared plus w h. So maybe this, I will say h prime c. Okay, so this is equal to half mvc, where h prime c is equal to just 30. So we're just using the properties from here. Okay, all right, and then we can say our vc therefore will just be equal to 0.5 by 2 divided by 32.2 plus 2 by 30, and then divided by 0.5 by 2 divided by 32.2, and then square root. We have our VC there is just equal to, our VC will just be equal to just 0.5, 0.5, sorry, I forgot to include something here. I need to include the speed, which we just calculated, which is a 31.48 squared, then plus which is W there, which is a 2 times HC, which is 30. Alright, so we have 0.5 by 2 divided by 32.2 plus 31.48 squared plus 2 by 13 divided by 0.5 by 2 divided by 32.2. Square root of that, 0.5 0.5 by 2 divided by 32.2 times 31.48 squared plus 2 by 13 divided by 0.5 by 2 divided by 32.2. Okay, then square root of that. So this we get a 54.06 feet per second. So we've seen we are getting the same answers whether we use the whole lot of this or whether we use this part. I just wanted to show that. So we found velocities at B and C. Let's go to finding the D. So in finding D, we do have this velocity here, which we just found. We have this velocity here. Okay, let me use another color which is more visible. So we found this velocity here, and this velocity will have some components. It has this component, it has another component there like so. Okay, so let's label this. So this is our VB, this one is our VB, this is our VB, therefore our VB here is 3 divided by 5, and our VB here is 4 divided by 5. Right, so using the vertical motion, we want to find the time. So say let's find the time it takes, okay, from B to C. Okay, so we are going to use this equation. S is just equal to S naught plus B naught T plus half AC T squared, and we are using vertical motion. Okay, here we have S is just equal to 0, S naught is equal to 30, AC is equal to minus 32.2, and B naught is equal to minus 305 by 31.48. So we can write this. So we have minus 32.2 by 0.5. So this will get a minus 16 T squared, and minus 3 by 31.48 divided by 5. We have 18.888 T. Then we do have plus 30 equal to 0. So we have T using the quadratic. We fit in those values. They are like so. Plus or minus square root. We have minus 18.888 squared. Then minus 4a, which is just a minus 16.1, and then 4ac, then 30, then everything divided by 2a. Okay, and our a is just minus 16.1. So we are getting just t. This is the time it takes. This t is the time it takes to move from B to C. So we are just taking the positive. So 18.88 squared plus 4 by 16.1 by 30. Then square root of that. There we go. And then Then we have we need the minus, right? So we'll say this minus then plus 18.888, then divided by 2 by 16.1 negative. So we have the time that is 0.8992. So this is the time it takes. Let's check it out again. Okay. Alright. So this is the time it takes to move from B to C. So with this time, we can use this equation now to find the horizontal component. So we can say, let's find D using V. We are using just the same. S is equal to S naught plus V naught T plus half AC T squared, where our S is going to be equal to our S. So we are moving from this point to there. Our S is equal to D, and our S naught is equal to 0, and our V naught is just going to be equal to VB, and it's positive this time around, so it's 4 divided by 5 by 31.48, and therefore our D is just going to be equal to, and then we have AC in this direction. This is equal to 0, so D is equal to so all this is 0, this is 0, this is 0. Okay, so this here we just get a 4 divided by 5 by 31.48, then times T, which in our case is 0.8992, and therefore our D is just going to be equal to, so 4 divided by 5 times 31.48 times 0.992. Okay, so this gives us a 22.65 feet. Okay, 25.65 feet. Let me move it somewhere there. Let me check it once more again, because we have distorted part of the information there. There is divided by 5. So we have 4 or 5 times 31.48 times 0.8992, 22.65. Alright. Okay, so here we meant another method. Okay, this is another method for speed at sea. Alright, so I hope this particular video was helpful. Let's just outline the final solution. So we have VB there. We found VB. Okay, there we go. So this is, let me just draw this here. We have our VC there like so. We have our VC there like so. Right, and then we have our VB like so. And then we found VC, which is this one here. And this one is, we forgot to put units, that's feet per second. This is feet per second. Okay. And then we have velocity there. Another, VC also. We just try to show two techniques of working it out, and then finally the range. Okay, so I guess this is about it. And I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and I'll see you in my next screencast.